Hello. So in this video, we will take a question which has come in this current year, with 2023 this year, and the question is from data structure, and it was on heap structure, and it carries 1 marks only. So for this 2023, the question, the word that we will solve for data structure. Now the first question, what I am saying here. So the question is, okay, now we can see that here a sequence of following sequence of numbers that has been given. Option A, B, C, D. So the question is, which one of the following sequences, when stored in an array at locations A1 to A10, forms a max heap? So, as we know, the property of the max heap is that the parent node of any subtree of the tree will have the higher value than all of its children. So heap is stored here in an array, and by seeing the sequence of that array or the numbers within that array, we can find out whether that represents a max heap or not. For example, so here the sequence of numbers, I'm just here I'm opening the window. The sequence of numbers is already given. So which is the sequence of number is that the sequence of number is 23, then 17, 10, 6, 13, 14, 1, 5, 7, 12. This is one sequence of numbers. Okay. 4 options have been given. Now I'm just writing the options one by one. So it will be second option 23, 17, 14, 7, 13, 10, 1, 5, 6, 12. Now C option is 23, 17, 14, 6, 13, 10, 1, 5, 7 and 15. And the last option D is 23, 14, 17, 1, 10, 13, 16, 12, 7 and 5. So the sequence I have written it here. The sequences 4 sequence have been given, and the question is, which of the sequence represents a heap in this video. So for that we will just consider each sequence one by one, and as we know, when array is stored at parent node is stored at location 1, then its children will be at a location twice of I and twice of I plus 1 locations. So in that case, if we draw the array of 10 elements, if we draw the array of 10 elements, and we are 2, 3, 4, 5, 6, 7, 9, 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are 10 positions in the array. So if the parent node, suppose the parent node is at location I, so its children will be, the left child of the node will be at location twice of I, and the right child will be at location twice of I plus 1. So we want to find out who will be the children for parent node 1. If I equals to 1, then left child and right child locations will be at 2 and 3. So if I equals to 1, so I will just copy the first sequence here. So first sequence is 23, 17, 10, 6, 13, 14, 1, 5, 7 and 12. Okay, so if we see the for I equals to 1, so for this position, if 1 is the parent, then its children will be 17 and 10. So in that case, 23, that is a parent node which has higher value than all of its children. So this parent node satisfies to be the parent of a max heap. Then if I equals to 2, that means this position. If I equals to 2, then its left child will be at location 4 and right child will be at location 5. That means that if the parent node is 2 and then left child will be at location 4 and 5. So in left child, both 6 and 13 has lower values than its parent. So 17 also satisfies the parent node of a heap. The next parent is this one, that is position 3. So if I equals to 3, so according to that formula, the left child will be at location 6 and right child will be at location 7. So if 3 is the parent node, then its left child is 14 and right child will be 1. Now though 6 is greater than 1, that means the right child, but the left child 14 is parent node 6 is less than its left child. So this cannot be child of this parent node. So we don't have to go further. So this cannot be a sequence or this cannot represent a max heap. Next we will consider the next sequence. Which one? That I'm writing here the sequence. Okay. So the sequence is option number B. So I'm copying that sequence 23, 17, 14, 7, 13, 10, 1, 5, 6 and 12. Now 23 has children 17 and 14, which is less than, parent is greater than both of his children. The next node is 2, whose children is at location. The children are the 7 and 13, and 17 is greater than all of its children. Then the next node is 14, which have children at location 10 and at location 6 and 7, which have 10 and 1. Both of these children are less than the parent. So this node also satisfies to be the parent node of a max heap. Then the parent node, next node we consider is 7. So 7 has children 5 and 6. Now this 7 has higher value than all of its children. So 7 also satisfies to be the parent node of a max heap. Next node is equals to this 13. Now 13 has only one child, which is 12. So and this child is less than the parent node. So 13 also satisfied to be the parent of heap, max heap. And the remaining nodes are all leaf nodes. So all leaf nodes are by obviously a max heap. So this total array represents a min-heap, represents max heap. Okay, represents a max heap. So which option is correct? Now option number B. This is matching. Then simultaneously, if we further so we have got the answer that for this sequence, 4 sequences have been given. Then among them, which of the sequence is representing max heap? Where this sequences is showing the elements which is stored in an array starting from location 1 to 10. So we have got the answer, but to clearly fully describe that no other sequence are matching with the property of the max heap, for that we are going for further considering further sequence just like C and D. So what is that? We are copying the C, sequence number C, and we will check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we are just copying the sequence of C option. So it is 23, 17, 14, 6, 13, 10, 1, 5, 7, 15. No, this is not 15, this is 5, okay. And this is 15. So, what I will say, that this is a parent node, which is greater than its children 17 and 14. Similarly, this is the parent node and its children are 6 and 13. So parent node is greater than all of its children. So this parent can be the parent of a max heap. Then 14 has children 10 and 1. So 14 has lower value than all of its children. So 14 satisfies the parent to be the parent node of a heap. Similarly, the next node 6, which has children 5 and 7. So see, though 5 is less than 6, but the child 7 has greater value than the 6. So this child cannot be this cannot be child of this parent. So we don't have to go further consideration. So this total array cannot represent max heap. Similarly, if we check the option D also, then we will find the same results okay, I'm copying the option D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I'm copying the options for D, which is 23, 14, 17, then 1, 10, 13, 16, 12, 7 and 5. So if we consider 23, which has greater value than all of its children 14 and 17. Similarly, the parent, if the parent node is 14, then it has greater value than its children 1 and 10. So it's satisfied to be the parent of a heap. So if we consider the next node 17, which has children 13 and 16, so parent node 17 is greater than all of its children. So this also satisfied to be the parent of the max heap. Now next node we consider is 1. 1 is less than all of its children 12 and 7. So 1 cannot be the parent node of these children. So this does not satisfy the property of a max heap. So what we will find, that only option B is satisfying to be represented as a max heap. So this is the answer. Okay.